Okay, so this is the lesson from Friday, and the topic was properties of logs. So I'm gonna do most of it, but I'm gonna skip around a little bit. There's a couple problems that I'm gonna do, and then I can have you try and check the answer key on some of them just to avoid the video being too long. So to introduce the different properties, I started with a couple little explorations. So I had students evaluate these first set of problems just using mental math and what we know about logs. So if we look at problem 1A here, it says log base 2 of 4 plus log base 2 of 8. Okay, so to evaluate log base 2 of 4, you're just going to think in your head 2 to what power is 4. So this is going to be a 2. And then log base 2 of 8, 2 to what power is 8 is 3. So this expression is equal to 5. Okay, and then we're going to come over to B and we're going to do the same thing. So we're going to evaluate this log using mental math. So this time we can actually multiply the numbers in the argument to get log base 2 of 32. And then 2 to what power is 32? This log is going to equal 5. Okay, and I want you to notice that these two answers are the same. Okay, and then we're going to do the same thing for the second one. So 3 to what power is 27? This is 3. 3 to what power is 3? This is 1. So this expression equals 4. And then over here, we get log base 3 of 27 times 3, which is 81. 3 to what power is 81? That's also going to equal 4. So then I had students look at A and compare it to B and see if they could complete this property here. Okay, so notice part A has 2 logs, and then part B has a single log, but the arguments are similar. Okay, so what I wanted them to notice is that you can consolidate these 2 logs into 1 log by multiplying the arguments. So this is called the product property of logs. So in general, if you have log base b of x plus log base b of y, you can write that as a single log in which you multiply the arguments. So that's the first property of logs. So then I had students do the second one kind of on their own. After we did the first one, they were able to do this a little bit more easily. So if we do something similar with this second set of problems, log base 3 of 81 is 4 minus 2 equals 2. And then over here, we get log base 3 of 81 divided by 9 is 9. And so this is also going to equal 2. Okay, notice this time we went from 2 logs to 1 log, but we had subtraction separating them, so that subtraction turned into division when we consolidated. Okay, so then we have 5 to what power is 125? This is 3. 5 to what power is 25? That's 2, so this expression is equal to 1. And if we were to consolidate that into 1 log in which we divided the arguments, we get log base 5 of 5, which is also 1. And so the second property that we talked about is the quotient property. Okay, and it says that we can take these 2 logs that are being subtracted, as long as they have the same base, we can smush these together into log base b of x over y. And these properties will be much more meaningful when we learn how to solve next week. All right, so there's 4 properties altogether. That's the first 2. So the next one is called the power property. Okay, so we're going to do something similar. We're going to evaluate these and then compare A to B. So this time we have 2 times log base 3 of 9. So 3 to what power is 9? This is going to be 2 times 2, which is 4. And then we have log base 3 of 9 squared. Well, 9 squared is 81. So 3 to what power is 81? This is also 4. And then this one we have 3 times log base 3 of 3 is 1, which is 3. And then log base 3 of 27, because 3 cubed is 27, is also 3. So then I had students try to come up with this property. Okay, so what happens from A to B here? So what I want you to notice is that the coefficient, this 2, goes up on top. This 3 goes up on top. So when you have a coefficient in front of a log, this property says that you can actually put that in the argument as an exponent. So y log base b of x is equal to log base b of x to the y power. Okay, and then the last property, the directions say use your calculator, but we actually did this without the calculator. So I showed them, these are actually exponential expressions. And so to explain this property, I had them change these to log form. So just a quick reminder to write something from exponential to log form. If you have something like 2 to the third equals 8, and I asked you to write that as a log. Remember, logs equal exponents. So you take the 3 and you're going to write 3 equals log base 2 of 8. So that's how you change from exponential to log form. So instead of a calculator, I had them change these exponential equations to log form. And that's what we did to complete this statement. So I had them put a box here because this is what we're looking for. Okay, so to change this to log form, we bring the exponent down. So the exponent equals log base 2 of what? Okay, and we noticed, well, if these two statements are true, then this argument has to equal 8. And so what we found is that this expression here just equals 8. Okay, and this is a property, so you don't necessarily have to understand, how I changed this to log form. You just have to know that when you have a exponential expression in this kind of funky form here, okay, if this base is the same as this base, then the whole thing equals the argument. Okay, so then we did that one more time here. So we changed this to log form. Bring the exponent down. This is going to equal log base 3 of what? This is what we're looking for. So if these two logs are equal, they already have the same basis, so they have to have the same argument. So this expression equals 81. So the final property, you've got this kind of messy exponential expression, and as long as these bases are the same, then the whole thing is just going to equal the argument. Okay, so here's a summary of the 4 properties, and then we just practiced using them. Okay, so sometimes you're going to be asked to expand a logarithm. So you're going to start with a single log, and you're going to be asked to pull it apart. So when you are expanding, you're going to use these properties from left to right. And then sometimes you're going to be asked to condense. And when you are asked to condense, you're going to take them from more than one log to one log. And so you're going to move backwards on these properties. Okay, so I'm just going to jump around. I want you to try a few of these. Actually, I'll do the first 4, and then you can try the you try and check on the answer key, which is posted in Schoology. Okay, so we're going to start by expanding. So it says write each log expression in expanded form. Okay, so what you're going to do first is you're going to look at your argument, and you want to figure out how many terms are in your argument. So we have log base 3 of 5x squared. So any terms that are separated by multiplication or division can be pulled apart. Okay, so I'm going to start by pulling apart the 5 and the x squared. Okay, and because they're being separated by multiplication, my property says that when I pull them apart, I can add. Okay, and then the last thing we want to do to expand this, we want to make this as long as possible. So you're going to take any exponents and you're going to use the power property to put them out in front. So we end up with log base 3 of 5 plus 2 times log base 3 of x. And this is your answer. Okay, so it's kind of messy, but that's called expanding a logarithm expression. So then this one, we have in the argument 6 divided by y to the third. So anything separated by multiplication or division can be separated. So we're going to write log base 7 of 6. This time we're going to put minus log base 7 of y to the third. And then lastly, you're going to take this 3 and you're going to put it out in front. So your final answer is going to be log base 7 of 6 minus 3 times log base 7 of y. And then that is your answer. Okay. And then the next one, you've got y to the third on top and x to the fifth on bottom. Those are separated by division, so we can pull these apart. We want to keep it with the same base. I'm going to put ln of y to the third minus ln of x to the fifth. The 3 comes out in front of the y, and the 5 comes in front of ln of x. Okay, so you want to make sure you put those exponents in front of the appropriate log. And then this last example, now it does have a little domain statement here, and that is just because if you look at this argument, this is invalid if x is equal to 4 or if x is less than 4, because the argument of the log has to be greater than 0. So what I want to point out in this example, so we've got x to the 4th divided by x minus 4. You cannot separate the x minus 4 because those are separated by subtraction. So we can only pull apart things that are separated by multiplication or division. So this is going to be log base 2 of x to the 4th minus log base 2 of x minus 4, and the x minus 4 have to stay glued together. So the only thing you can do to simplify here is to put this 4 out in front. I'm actually going to go ahead and just do that. Okay, and then if you want to put that domain statement back in there, you can. That's just to show you, especially in my math lab, sometimes they have these domain statements. It doesn't change the approach. It's just telling you, acknowledging that that is invalid if x is not greater than 4. All right, so you can go ahead and try these two, and then if you want to pause and check your answers, the answer key is posted on Schoology. All right, so then we moved into condensing. So when you're condensing, you're taking more than one log and you're like smushing them together to create a new logarithm. Okay, so we're going to be using the properties backwards. So for this one, we have a plus sign here. So we're going to write log base 3. We're going to take our arguments, 5 and 7, and we are going to multiply them. Okay, the directions are going to say write the expression as a single logarithm. So then I get log base 3 of 35. Now sometimes after you smush them together you can simplify, but we can't do 3 to what power is 35 without a calculator, so we're just done. All right, now when you're writing as a single log, any coefficients, now those coefficients are going to go to the top of the argument and become exponents. Okay, so we're doing the reverse of expanding. So we have ln of a squared minus ln of b to the 3rd. So we're going to write ln of, subtraction becomes division, so we get a squared over b to the 3rd. Okay. And do a couple more together. So this one, we're going to put the 3 up on top. And then all we have to do here, these are the arguments, and we have a plus sign there, so we're going to multiply log base 2 of x plus 2 to the 3rd times x minus 3. And that's my entire log, that's the entire argument of my log. Okay? And then one more. So this one, I can take this 4 here and put it up on top. And the subtraction tells me to take these two arguments and I'm going to divide them. So I have x squared minus 25 over x plus 5 to the 4th. Now what you should notice here is that we can actually simplify this argument. So if you can simplify an argument, you can go ahead and do that. So I'm going to factor the top in x plus 5 times x minus 5. And then I've got x plus 5 to the 4th on the bottom. So I can cross out the x plus 5 on the top and make that x plus 5 cubed. And so my answer, my final answer, is going to be x minus 5 on top over x plus 5 to the 3rd on the bottom. All right, so that's how we consolidate. And then the last section was practice with that last property. And then notice the directions here. We're going to evaluate. We're going to find the exact value. So our answers here should be numerical. Okay, so think about that last property. So this problem here looks a little intimidating. But remember, if these bases are the same, you've got this kind of messy exponential expression. This is just going to equal 7. So you should have to do minimal work to answer that one. Okay, this one, remember ln in the exponent has a base of e, so my bases are the same, so this just equals 8. Okay, and then one more with this, or I think we have a couple more with this final property. So notice this one, I have to consolidate my exponent into one log. So I'm going to write 6 to the log base 6 of, I can smush these together using multiplication, so I get 15. And so then this whole thing just equals 15 because now I've got my property in place, and so it's just going to equal the argument. Okay, and then one more. So the problem here is I've got this 2 here that's not supposed to be there if I want to use my property. So I'm going to put my 2 up here. I've got 3 to the log base 3 of 16. And now my property works, and this whole thing equals 16. Okay, and then the last couple examples is just showing you we can't evaluate these logs individually, like 3 to what power is 24, 3 to what power is 8. But if we use our property to write this as 24 divided by 8, which is 3, now we can actually evaluate this log to get 1. So sometimes when we consolidate, it allows us to evaluate. And then the final one, we're going to put this 2 up here. We're going to make that log base 4 of 4 squared is 16 plus log base 4 of 4. And so that gives us log base 4 of 16 times 4 is 64. 4 to what power is 64? This whole thing equals 3. All right, so hopefully that video was helpful. Let me know if you have any